Hi guys, and welcome back to another video. Today on the workbench we have got this circuit board. I'll give you 1 second to identify what problem with it is. 1 second's up. Okay, it should be quite obvious because it is in the center of your screen and towards the lower third of your screen. Okay, if you look, we've got a nice V notch in the middle of this triac, and we've got a burnt section over here. Now, first we have to figure out what this board is from. Okay, so let's scoot the board away. And this is a Scotsman MC46 Ice Machine. This is the type of ice machine that this board came from. Okay, basically this is a commercial grade ice producing machine that produces ice. Every 20 or 25 minutes it dumps a load of ice into the lower buckets, and this circuit board controls everything. As I said, it is the Scotsman MC16 or MC46. They both use the same circuit board. Okay, and this section of the board that's nicely toasted, this triac, if we look over here, let me just zoom you in a bit more. If we take a look just at this operational page, really. Okay, you can see over here that this is all on the control card. Okay, triac goes over here, what is over here, and it operates the fan motor. Okay, now the fan motor in this unit had seized up, and I think that's what might have taken out that triac. That seized up might have caused an overload or whatever, and basically blew that part of the board. If we look over here, we can just confirm there's a varistor over there. So this is the general area, and there's the triac. Okay, but what's nice is this client has got 2 of these machines similar. This is a photo I took of the other machine's board. Okay, what you'll notice difference, the only difference really that you can notice besides the blown triac and that, if you look over this section here, we've got 3 relays over here. Over here, this relay actually burnt out or went faulty, and we needed to sort that out. That relay was for the water solenoid that let the water into the tank, and that. So that relay burnt out, or it got faulty, and the only way we could get them going in a hurry was to put another relay and just run some jumpers over there, which has worked. So we're going to be leaving it like that for now, but because this machine is working, it's the only machine they got at the moment while this one's out of action. So obviously we want to get this board going as soon as possible. So let's take it from there. So if we look a bit closer at the good board, you can see that our triac there is a BT137 triac. BT137 600G. There's the varistor that they talk about. There's a resistor, although they don't talk about it, it's just in the image. There's a resistor there. And if we punch down a bit further, so there's the triac center leg, the varistor, the 2 resistors, and the TLP3063. And the TLP3063 is basically an opto-triac driver, which is, if we look at the data sheet, I don't know how well you can see it over here. Yes, my screen protector is a bit cracked. But it's got a photodiode, phototriac, and zero crossing detection. This basically drives the triac. Sorry. Let's get another picture back here, showing you off page. Basically drives the triac from the microcontroller to act as an isolation. So whatever happened to the poor triac, it probably went and pushed out power along its gate, which blew up this section over here and toasted the resistor and started causing arcing and things like that. So basically what we have to do is we have to rebuild this section. So I'm going to pull out this opto triac, I'm going to pull out the resistor, I'm going to pull out the triac and that, and we're just going to clean this section up, see if we can get rid of this carbon just by brushing it off. If not, we might have to cut a piece of this board away and basically rebuild. And I don't think this is a 3-layer board. No, it looks like basically a 2-layer board if I hold it up to the light. Let's see if I can show you what I'm seeing. Torch. So if I shine the light on the back of the board there, you can see it's doesn't look too bad. Whoa, that's bright. So I'm going to start by pulling off these components, and then we can brush the board with some electronic cleaner, Flam, which I believe is just flammable, but this is basically high-grade alcohol. So we're going to clean the board up and then take it from there. So let's go. Okay, so I have removed all the triac, the opto-triac, the resistors. So now I'm going to try to scrub this part of the board and see how damaged it really is. Because I can see the actual matting in there. Don't know if you can see that. So this board is toast. Okay, basically as you can see I've scrubbed it quite a bit, and that matting is there, the carbon is still there. So what I'm going to have to do is basically cut out the section with the carbon that's carbonized basically, and then shouldn't be too much of a hassle, because if it's just the section that's damaged, it's one resistor that goes across there, one leg of the opto, this trace over there. If you look underneath, we've got another trace coming in there. So it doesn't look too bad once I cut this out. And then of course I've got that other board that I can use for a reference. If I do need it during the week, I can pull it out, check whatever traces I need, or bring it back for a day and then figure it out and then fix this board. So I'm going to try and bite away at this now once I get my cutters out of my drawer, and then we'll see how it looks. Okay, now as you can see, I have nibbled out all of the little fiber strands there, fiberglass strands. So that part should be nice and safe. So I'm just going to cut these other traces a bit back, little tracks, and then I'll need to find out what, basically repopulate resistors, find an opto triac, find a triac, and then start putting this thing back together. Okay, now just thoughts I had just now. Before we go and order the parts for this board, we first need to make sure that the damage to this driver, to the opto driver here, did not actually travel back and mess up the microcontroller, because if it did, then we're out of luck and basically we'll need to get a new board. So what I've done is I've just hooked up a power cable to where the live and neutral will go. Going to plug it in. I know I did break off 2 LEDs that I'll sort out later, but let's first see it. We should at least get an alarm light after about a second or so of it being plugged in, just so it says, okay, now I can't see these inputs from the temperature sensors and that. So let's give it a shot before we go and put more parts in it. Okay, make sure nothing's going to short out, and away we go. Okay, so you see that we did have a delay. We unplug it. So once I plug it in, I'll count until this light comes on here. I did also replace the fuse. I'm going to actually change the whole fuse holder because I did notice there was an arc on the one side of the fuse, but the fuse did blow as a result of it. That's how they knew that there was a problem with their machine. So let me not touch the fuse while I do this. Okay, plugging in 3, 2, 1. 1, 2, 3. So that's a delay. It's not like an instant thing on, so it looks like the microcontroller is working. So I think we're good to go and swap these parts, and let's see if it works. Okay, so here we go. I've sorted out the LEDs. Just had to make the legs a bit longer and re-put them in there. Now I've rebuilt this section over here. Whoa. Based on the other one, and also the data sheets for the triac and the opto driver. The only resistor, the 100 ohm resistor I had, was a half watt, and then there's my quarter watt 47 ohm resistor. And if you look at the back, that's how we've touched it up there. So before I clean it off, nothing shorting, let's plug it in and see if it goes bang. Oh, I've also replaced the fuse holder and put the replacement fuse in there, 6.3 amp slow curve, because this fuse protects the board through the transformer, and it also takes the live and feeds it out to this contact, which runs the compressor. Okay, plugging in 3, 2, 1. And there we go. We got our power light, and we got our alarm light. No other lights there. Off and on. So I'm going to now take this on site, hook it up into the machine, and then see if I did actually get this part to work fine. I'm not going to touch it now because it's live, and these pins are, and the power pins are live there as well. There, so let me go put it in, and then I will get back to you in a few minutes, a few seconds. Okay, so I'm at the site, and this is the customer's working MC46 machine with basically 2 heads and ice. Okay, so now let's go over to the little one that I've just put the board in, and we're going to see if it comes to life. At the moment it's on this water filling cycle, so we'll just leave it and see. Okay, partial success. As you can hear, the water is sloshing around. Circulation pump is running over there. Compressor's running, and the triac controlled fan is operating fine. It varies its duty cycle depending on the temperature of this coil here, and that is determining your pressure. Only thing that's not working is the freezing operating light. Could be a damaged trace, could be the way I fixed the LED. but we can sort that out later. And we're just going to leave it for 25 minutes or so. As you can see, there's no ice in there at the moment. So we'll just wait a bit and then see what happens. Okay, so we're back again. Let's see what this thing has been doing in my absence. Okay, fan is still busy running. It's been, I'd say, just about over an hour. And if we look in the bin here, we have got some ice. So it's actually done quite a few cycles, maybe 3 or 4 cycles. And there's some nice looking chilled ice. So only thing left to do is to sort out this LED that's not working, but the main part of the system's working. It's making ice, so that's good. I hope you enjoyed this ice machine repair video. If you did, give it a thumbs up and like and share. Thanks guys.